University in Canada. The topic I'm presenting today is toward new real-time digital twins of construction sites, developing high-LOD 4D simulation based on computer vision and RTLS. Before I start, I would like to introduce my supervisor, Dr. Amin Hammad, and my colleagues, Ms. Ghazaleh Torabi, and Mr. Ali Ghelmani, and Dr. Michel Guevremont. The Industry 4.0 is considered as the future of manufacturing. Towards Industry 4.0, the manufacturing industry are becoming digitalized. The digital twin has the potential to improve the product throughout the product's life cycle, as you can find in this figure. Overall, the digital twin helps better visualization and the capability of integrating different types of data in one simulation model also helps improve the collaboration between different stakeholders. Moreover, with continuous real-time monitoring, more semantic information can be obtained, which provides the possibility in making prediction and optimization. However, generating a digital twin in the construction industry is actually difficult because the construction industry has massive amount of data, and these data usually are difficult to collect in real time. In addition, there is a lack of factory level accuracy, but actually generating digital twin is feasible because we have the assistance from the foreign technologies, including the BIM, IoT, and new data capturing technologies such as RTLS and LiDAR. And also we have the new intelligent computer algorithms of machine learning and data mining. So BIM provides a very good platform for massive data management. A high level of development 4D BIM can be the basis of developing the construction digital twin by linking the high-LOD BIM and the high-LOD schedule. So previous applications of 4D simulation include conflict detection, construction plan optimization, improving safety management, and also claims management. This video shows one of the previous work of our team. It shows a high-LOD 4D simulation of the construction of a powerhouse to analyze the shifts in the critical path of schedule caused by delays. The emergent technologies are also very important in generating the digital twin of construction. The evolution of IoT can provide more possibilities in real-time data collection. And with the help from the new data capturing technologies, data capturing now becomes more diverse and accurate. Moreover, the advanced computer algorithms of data mining and machine learning allow us to process this data into useful semantic information, which makes the simulation more realistic. So these are the examples of using the digital twin for building energy management and BIM model reconstruction. In this paper, we want to explore the possibility of developing high-LOD near real-time digital twins of construction sites using RTLS and computer vision. Digital twin has three parts, which are the physical space and the virtual space, and also the data processing layer, which is the connection between the two spaces. In the physical space, data is collected and processed to be used in the virtual space to create the virtual replica. And the useful information can be retrieved from the virtual space to assist the management in the physical space using the simulation. The proposed method is developed following this structure. A high-LOD S-Pen 4D BIM is used to generate the initial simulation model of the digital twins. GIS data is imported to integrate the data of the site into the 4D simulation model. In the physical space, the video of the site and the position of the construction resources are captured by cameras and RTLS sensors respectively. And these data are processed to extract useful information, which will be integrated to become the inputs to the update of the 4D as-built 4D simulation model. Then by analyzing the statistical data from the as-built model, the progress of the construction activities is identified to perform the productivity analysis and ultimately progress monitoring. In addition, the movement of the construction resources are also checked in the simulation model to perform proximity detection. And with the historical data like the recorded trajectories and proximities, risk heat map can be generated for the use of safety monitoring and risk prediction. And as a result, adjustment can be performed to improve the project management regarding the productivity and safety. This figure shows the process of developing the as-planned initial 4D simulation model. First, we need to define a suitable LOD which can achieve all the requirements of a certain application. And for example, in the case of foundation construction progress monitoring, the focus is on the outcome from every micro task, such as building footing formwork, adding footing reinforcement. Then we prepare the 3D mockup as shown in this figure. And accordingly, when defining the schedule, the unit of time is set to minutes, and the schedule should detail all related micro tasks. The next step will be updating the simulation model to be as built using data collected from the construction side. By using computer vision, we recognize the atomic activities of workers. The algorithm we use is YOVO 53, which is developed based on YOVO. And by finding the prominent atomic activities in the temporal time window, the microtask can be identified. In addition, object detection is performed for the finished object by using the information from the microtask. And so by using the information from the microtask and the detected finished object, the productivity can be analyzed. At last, we detect the position of workers and the finished element in order to recognize the corresponding elements and tasks in the simulation model. With RTLS, the position of construction resource can be obtained. The raw RTLS data usually comes with errors caused by different factors, for example, occlusions. So to minimize this error, extra processing is applied. The 4D simulation model will then be updated according to the smooth RTLS data. The digital twin based on computer vision and RTLS can improve the construction management from the following aspects. The progress monitoring can be performed through microtask recognition. Knowing the as-built micro schedule, productivity analysis can be performed. Besides, trajectories of workers and equipment are recorded and the risk heat map can be generated. For example, the proximity heat maps and the occupancy heat map. These heat maps can be used to improve the construction safety. A case study is made on the construction site of a power substation. The site dimensions are 110 meters by 70 meters. 4 posts of about 10 meters are built near each corner of the site. A camera is installed on the pole to capture the video, and a total of 9 RTLS sensors are installed. In addition, on the top of each pole, an antenna is installed to connect the sensors and the camera with the server computer in the site office. To set up the RTLS system, tags are attached to the hard hat of 5 volunteer workers. In addition, tags are attached on 3 kinds of equipment. So which are the crane, telehandler, and the boom lift. Revit is used to develop the high-LOD 3D mockup of the project. The microschedule is generated using a Microsoft project. Rather than using a typical BIM software to generate the 4D simulation, the 3D BIM and the microschedule are imported to Unity for generating the 4D simulation. Compared with the typical BIM software, a game engine has its own benefits as it is programmable, path and motion planning are feasible. The game engine is also able to perform collision detection and animate complex tasks. And here is the example of the digital twin using the information from computer vision. This video shows the physical space captured by camera, and here is the virtual space. In the virtual space, the activity and microtasks of each worker are shown above the workers. Since the positioning here is based on only a single camera, the positioning is not very accurate. And when an object is finished, it will be shown in the virtual space, as you can see in the video later. And this is the example of digital twin using RTLS data. In this video, the worker is approaching the equipment. When there is a proximity detected, the proximity will be recorded. The movement of the worker and the equipment in the virtual space is matching the physical space. However, we can notice some unnecessary rotation in the virtual space, which is caused by the positioning errors.
We have 1 minute and 30 seconds.
Yeah, you can include series-based atomic activity and microtask recognition provides useful information for updating the as-built 4D model, 4D simulation. And RTLS data analysis increased the LOD of the simulation regarding the movement of construction resources. The case study shows that developing digital twin of construction site based on RTLS data and computer vision is feasible. In the future, we will improve the site setup to reduce the errors of RTLS and the series-based atomic activity recognition. And we will also integrate other types of real-time data collected on the construction site to make more realistic simulation. For example, the weather data. And moreover, we will develop methods that can obtain more semantic information from the captured data for construction management improvement. And this is the end of this presentation. Thank you.